Hello and welcome to Best EDU Season 2. This is going to be the first episode and we're going to be going over Unit 5.1, 5.2, and 5.3 for Algebra 2. So, pretty simple. Power rule, quotient rule, power product rule. That took me a while to memorize, but we're going to get it down. So, a to the square root of x times a to the square root of y. The square roots add. You got a plus x plus a to the square root of x plus y. Simple. Quotient rule. Divide, right? A to the square root of x divided by a to the square root of y equals a minus y. Simple. Power rule. A to the square root of x times the square root of y. They just multiply. You can see it up here. Power product rule. AB to the square root of x. The square root goes to both of them. Take a screenshot. Do whatever you'd like with it. You need to memorize these. Now, I know I said that was it, but I have one more that you have to get down. The nth root of a is equal to a to the square root of 1/2. That is very, very important that you know that, and I'll explain why. So before I start explaining nth roots, I'm going to explain this real quick, and it'll be super, super simple. So the 4, of course, comes in, turns this x to 4, turns this to 6, and this to 4. So we get 3x, 4y, 6, z, 4. And there's your answer. Just wanted to clarify that. I hope you understand what I'm saying here. Alright, so now we're getting to nth roots. Now this applies to both unit 1, 2, all 1, 2, and 3, 5.1, 2, and 3. So it is important that we understand this concept. So we have the square root of 5 to the root of it is cubed. My apologies for bad vocabulary. So I'm going to show you what to do, and then I'm going to explain it. So this becomes 5 to the square root of 3 over 2. Okay? Let me show you what I did there. So we took the 5, we moved it over, right? When we put the 3 up here. Now, we always know that because this is a square root, there's a little 2 here. That 2 is where this 2 comes from. Of course, this can change. We could put a 4 there. We could put a 5 there. We could put a 13 there. We could put any number there. But it's important that we understand there, when there's nothing there, it's always a 2. Then the 3 just comes up here on the top. And this will be the same throughout the rest of this lesson. All right, here's another one. I'm going to try and get it a little bit more memorable, okay? So we have 4 square root, fourth root. That's where the sound comes from when I say nth root. So fourth root of 4 to the squared. Sorry. Let me re-say that. I did that a little wrong. Okay? The fourth root of 4 squared. Simple, right? So we see this is higher up right here. Now this rule doesn't maintain the same always. Things can change, but for 5.1, 2, and 3, this is all you need to know, right? So because this is on top and this is lower, right, we know that the 2 is going to go here, the 4 is going to go here, it's going to go like that. And that's your answer. Super, super simple. All right, so now this is a part that I think messed up all the units for me, encouraged me to make this video. So now I'm going to try and explain it to you now that I've figured it out. So the cube root of negative 216, right? So we know the cube root of 216 is 6, right? So we've got, to get 216, we've got a negative 6, a negative 6, a negative 6. I don't know why I thought to write a 16 there. That didn't make any sense to me. That equals our negative 216. Pretty plain and simple, right? So I want to show you a trick that I think my teacher kind of messed up on and didn't quite explain perfectly. And hopefully I can explain this a tiny bit better. So because this is odd, it has a rule, right? That positive is positive and negative is negative. Either I wasn't paying attention or it just didn't come across right. I'm going to explain this part more. So the positive equals positive and negative equals negative means that the answer that we get from here is going to be positive if this is positive, or negative if this is negative. This is negative, so our 6 here, which is our answer, 6 for this equation, negative 6 is our answer. Being that this is negative here, this is also going to be negative. I'm going to show you another example where it's positive, and I'll show you how that changes. All right, here it is a tiny bit different, right? This here is an even number. When it is even, it is plus or minus. Our answer will be plus or minus. Like the other one where it was odd is odd, or sorry, even is even. No, that's not the right word. Positive is positive and negative is negative. This one is where if it is even, it will be plus or minus, right? So the answer to this for 81 is going to get us plus or minus 3 because this is even. All right, so let's build upon what we just learned and throw back to the beginning of this lesson. So at the beginning of this lesson, I showed you that we can convert from a square root where it has some parentheses around it and it has a power on it, right? I explained that previously. So now I'm going to show you how to reverse that, but I also need you to listen to what I said just a moment ago talking about that. You'll kind of see what I mean in a second. So here we have 4. Let's rewrite the 4 there, make it a little bigger, right? 4 to the square root of 5 over 2, okay? So like we said before, because the 2 is on the bottom and the 5 is on the top, we get our square root out. The 2 goes here. The 5 goes up here. And the 4 goes in there. Simple, right? What we just learned, though, is that this 2 makes the answer to this plus or minus. So we know that our answer is going to be plus or minus something, right? So the first step we want to take is square rooting the 4, which square rooting the 4 is going to get us 2. And then to the power of 5 gets us 32. So our answer is plus or minus 32. Is that right? Yes. Yes! Like you need to know the rules from the last unit, this one has one rule in particular that you need to know. And that is that a to the power of negative m equals 1 over a to the power of m, right? So the negative goes away when it goes here and goes under. Same thing happens here, except it's opposite. So it just switches backwards like we did before, but goes back to its original state. You kind of get what I'm saying? It'll be super simple after I show you a couple of examples, and then you'll know what I'm talking about. All right, so my teacher showed me this example. I didn't get it at all, mostly because I got no sleep the night before, but hopefully that I can explain it now, and it'll make more sense to you. So we have 7 to the square root of 1/4 to the square root of 1/2, right? Well, it may look complicated, not know where to start. I'll show you what to do. So, like we said before, when we have a square root on the outside, it multiplies to the inside square root. So what we're going to do is, in order for these two to multiply, it adds, fix my wording there, but in order for them to add to one another, they need to have an equal base, right? This is a 2, this is a 4. So we can move this up to 2/4. Simple. Now the bases match, okay? Now what we're going to do, and you have to acknowledge this, see how this 2 went up? See how this 2 went up? Now we're going to add it. This becomes 7 to the square root of 2, see, that's where you mess up, to 3/4. That's your answer. And the reason being is that we have a 1 here and a 2 here, and that's because we moved this up. And that's what you need to realize with this in particular, is that these bases need to match and these add. Like we said in the rule from Unit 5.1, that they add together. I think you kind of get what I'm saying here. So now this question, I think, does a really good job at taking all the rules and putting them together. So pay attention, write these down, and just kind of follow and try to understand what I'm saying here. So 4 to the power of 5 times 3 to the power of 5, all to the power of negative 1 over 5. Okay? Hold on. Give me a second. So with this one, we want to take and go 4 to the power of 5 and put these on both sides. Remember from our rules from Unit 5.1, it's the same. And this goes negative 1 over 5. They multiply, right? Multiply. Same over here. 3, 5 to the power, or 5 times. You see what I'm saying? You see what I'm saying, right? So when we do this on both of these, this becomes 4 to the power of negative 1 and 3 to the power of negative 1. Now, if we know anything about the rules we discussed at the beginning of 5.2, we know that a to the power of negative m equals 1 over a to the power of positive m, right? So we're going to be able to move these. Hold on, I kind of wrote that really wonky. There we go. And you're going to kind of see how we work this here. So this will become 1 over 4. Why does that happen? Because the 4 got changed from a negative to a positive. So the 4 is technically, like all numbers, has a power to 1, right? Because we got rid of the negative. So we get 1 over 4 times, and it does the same here with the 3, 1 over 3. And that is your answer. I was wrong. That's not your answer. So actually, I need to correct myself here. So we remove this little box here. And we keep working because I was wrong. So this comes across, the 1 comes over, and the 4 times the 3 gets us 12. That is your answer. You need to simplify it as much as possible. That is something that I mess up a lot, and I guess we'll have to do a video explaining that, right? So that's how you do this, and that's how you apply this in this manner. You kind of get what I'm saying? If you're listening to the audio version of this, which I'm not going to make an audio version of this, but if you're blind and you're listening to this, I'm sorry, I can't help you because I'm going this, this, and this. All right, here's another one. So we have 5 over 5 to the power of 1/3, okay? And we need to simplify. So what we're going to do is we acknowledge, like I said in the last one, which I think, again, the last question was such a great example because it explains it so well and all the different terms and ways that it goes. So this one, there's automatically a 1 up here, right? And like, not the last, maybe the one before it, we have to match the bottom. So we would get, this becomes 3/3. 3/3 still equals 1, okay? So what we're going to do here, 3/3 equals 1. So we're going to take 3/3 minus 1/3. Remember Unit 5.1, we were going over the different rules, and when we have numbers, a number over a number, and they divide, the exponents subtract. So that's what we're doing here. So then our answer here is 2 over 3, which is going to be our answer because the 5 becomes 1. So actually it's 1 to the power of 2 over 3. All right, now I thought I should probably just run through these two just to kind of get in your mind how these two work. So we have cube root of 12 times the cube root of 18. So because we have two matching roots here, we just multiply across. And when we multiply 12 times 18, we get 216. And we keep the root. And then the cube root of 216 is 6. And it's as simple as that. Pretty simple. Not sure if that would be on a test, but this still leads on to other concepts that we're going to have to go through later in this lesson. Now, this one is exactly the same. So, same numbers. We have 80 divided by 5. That becomes 16 right here. And there you go. It's the same thing on both sides. Alright, we're going to take this one very slow because I'm just barely learning it myself, but I can explain it. So, the cube root of 137, we need to simplify this, right? So we're going to start over here. We have these multiples of numbers. We are choosing this because there are 3 digits per thing. That comes from this. That gets us that. You kind of see why we're doing that? So 2 times 2 times 2 equals 8, 3 times 3 times 3 equals 27, 4 times 4 times 4 equals 64, 5 times 5 times 5 equals 125. Right? And then what we're looking for is one of these numbers here to be able to divide into 135, which 27 does. So 135 divided by 27 is 5. So we're going to take this down and we're going to write it like this. We're going to go 5 times, hold on, let me write this a little differently, 27 times 5, okay? So 27 times 5 is 135, which is a multiple of 3 times 3 times 3. You can see what we're doing here, right? If you need to, please pause this video. I should have said that at the beginning. Pause this video and analyze kind of what I'm doing, right? Because this is a complicated topic. So we have our numbers here. Now the cube root of 27 is 3, right? It's 3. So we're going to bring a 3 out here, okay? And here's our square root. And then this 3 stays the same, right? Because we just did the little root thing here, okay, to get that 27. This 3 stays here, and the 5 stays in there. Kind of getting what we're doing, right? Let's see if we kind of work this backwards and see if that gets it a little more. So we've got the 3, which came from our 27, and that's the cube root of 27 is 3. That's how we got that. 3 stays the same, the 5 stays the same. Those both drop down. They stay the same. Okay? And we got the 27 times 5 because 27, right? We got the 3. We need to kind of back up here. So we got the 3. 2 times 2 times 2 equals 8. 3 times 3 times 3 equals 27. We're trying to find a multiple here. And 27 divides into 135. 8 doesn't, 64 doesn't, and 125 do not. 27 does. So that is why we did 27 times 5. The 27 then gets rooted and becomes 3. That's how we got that answer. I hope you can kind of understand what we're going for there. It's a confusing one, and actually I've done like 10 takes trying to explain this one, and I kept having to go back. So I'm going to try and dumb it down a little bit. So the 5th root of 7 over the 5th root of 8 is what we're solving for. We have our 5 here. And like the last question, we do 2 times 2 times 2 times 2 times 2 equals 32. 3 times 3 times 3 times 3 times 3 equals 243, and so on, right? But we take our 32 is divisible by 4. 243 is not divisible by 4. This gets us 8, right? Sorry. We're solving for our 8 here. And we've got our 8 is here. So what we're going to do with our 4 here is we're going to multiply and give the 5th root of 4 and the 5th root of 4, cut video. Okay, so now we're going to take these numbers, and 7 times 4 is 28, and 8 times 4 is 32, right? And we're going to put our square root 5 over here, square root 5, and that is your answer. All right, cube root of 64, y to the power of 6. Kind of get what I'm saying here? Okay. This is going to be pretty simple, pretty smooth. So we have, and this is a lot calmer than the last one we just did. I just want to let you know it's a lot more peaceful. and it's not as stressful as the last one. So hopefully this one kind of free your mind up a little bit. Okay. So, like we said before, remember the 6 goes on the top. And this is from 5.1. 6 goes on the top, 3 goes on the bottom. Like so. 6 divided by 3 equals 2. Mwah. 64, square root of 3 still stays there. But then we get a y squared. 64 cubed is 4, I believe. I think, if I'm not mistaken, am I on the right page? Yes, I am. 4y squared is your final answer. All right, so let's ramp it up a little bit. We have the 4th root of 15, okay? So 4 goes into 15 3 times. 4, 8, 12. 4, 8, 12. I don't know why I had to think about that, right? So what we can do is we'll have x 3 to the power of 3 times x to the power of 12. Remember, when they multiply, they add to 15. So this can very simply be just simplified to 4 to the square root of x to the 3. But that's kind of a confusing way to put that. So I'm going to kind of stress it out a little bit. So we got 3 times 4. 3 times 4 equals 12, which is what we got here. Now, we take the 12, and we're going to go like this. We're going to go 15 minus 12. 15 minus 12 is 3. That's why we put the 3 here. Kind of get what I'm saying? You can tell this video is getting a little long, but I'm going to try make it a little faster, but also maintain our material.